Imagine a signal, faint but deliberate, pulsing through the vast emptiness of space, sent by a civilization not unlike our own, reaching out across the stars at the precise moment our telescopes turn their gaze toward the heavens. This tantalizing possibility drives humanity's relentless search for life beyond Earth, a quest that has taken us from backyard stargazing to the edge of the cosmos. Among the countless worlds scattered across the galaxy, one planet has emerged as a beacon of hope in this cosmic pursuit: Proxima b, an Earth-sized exoplanet orbiting the closest star to our Sun, Proxima Centauri, just 4.2 light-years away. Its discovery has ignited imaginations, fueling dreams of distant worlds where life might thrive, perhaps even mirroring our own existence. But what makes Proxima b so special, and why does it hold such promise in our search for answers to the ultimate question: are we alone? Proxima b orbits its star in a delicate balance, nestled within the so-called habitable zone, where conditions might allow liquid water to pool on its surface, a key ingredient for life as we understand it. This region, often called the Goldilocks zone, is neither too hot nor too cold, offering a sweet spot where chemistry could spark the beginnings of biology. Yet, Proxima Centauri is no ordinary star. A red dwarf, smaller and cooler than our Sun, it burns with a fiery temperament, prone to violent flares that unleash torrents of ultraviolet and X-ray radiation. These outbursts could scour a planet's atmosphere, stripping away the very elements needed to sustain life. For Proxima b to harbor life, it would need a robust shield, perhaps a thick atmosphere or a magnetic field akin to Earth's to withstand this stellar onslaught. The challenge of studying such a distant world, obscured by the glare of its star, has long frustrated astronomers. Until recently, our view of Proxima b was little more than a blurry hint, a shadow in the starlight captured by ground-based telescopes, struggling against Earth's turbulent atmosphere. Everything changed with the arrival of the James Webb Space Telescope, launched in late 2021, a marvel of engineering that has redefined our ability to peer into the universe's deepest corners. Positioned 1.5 million kilometers from Earth at a stable gravitational point known as L2, this observatory operates in the cold, silent vacuum of space, free from the distortions of our planet's air. Its 6.5-meter mirror, a golden honeycomb of precision, captures light that has traveled for billions of years, revealing details once thought impossible. Unlike its predecessors, this telescope sees in infrared, slicing through cosmic dust to unveil the secrets of distant worlds. In 2023, it turned its gaze toward Proxima b, delivering a breakthrough that sent ripples through the scientific community. For the first time, astronomers saw the planet in unprecedented clarity, its surface features emerging from the haze. The telescope's instruments, including the near-infrared camera and the mid-infrared instrument, detected traces of water vapor, carbon dioxide, and methane in the planet's atmosphere, molecules that, on Earth, are often tied to life. These are not mere curiosities, they are potential biosignatures, chemical whispers that could hint at biological processes unfolding on a world beyond our own. The discovery of these gases does not confirm life, but it sets the stage for a thrilling possibility. Water vapor suggests the presence of liquid water, perhaps in vast oceans or hidden subsurface reservoirs. Carbon dioxide could indicate a dynamic atmosphere, capable of trapping heat and stabilizing temperatures. Methane, a molecule often produced by microbes on Earth, adds an extra layer of intrigue, though it can also form through volcanic activity or other non-biological means. The data from Proxima b paints a picture of a world that might, against all odds, sustain some form of life. Yet the violent nature of Proxima Centauri complicates this story. Its flares could bombard the planet, potentially eroding its atmosphere over eons. Scientists are now racing to determine whether Proxima b has the defenses to endure this cosmic assault. A strong magnetic field, generated by a molten iron core, could deflect harmful radiation, much like Earth's magnetosphere shields us from solar storms. Alternatively, a dense atmosphere rich in greenhouse gases might absorb and mitigate the star's fury. These questions remain unanswered, but the telescope's observations have given researchers a starting point, a foundation to build upon as they probe the planet's secrets. The James Webb Space Telescope's ability to study Proxima b owes much to a technique called coronography, which blocks the blinding light of a star to reveal the faint glow of its orbiting planets. This method is like placing a thumb over a flashlight to see the dim fireflies dancing nearby. By isolating Proxima b's light, astronomers can perform spectral analysis, breaking it down into its component wavelengths to reveal the chemical makeup of the planet's atmosphere. This process has uncovered not just the presence of key molecules but also clues about the planet's climate. Cloud patterns, temperature gradients, and even hints of seasonal shifts are now within reach, offering a glimpse into a world that might resemble our own in unexpected ways. Proxima b's proximity to its star, just 1/20th the distance between Earth and the Sun, means it completes an orbit in a mere 11.2 days. This close embrace likely results in tidal locking, where one side of the planet faces perpetual daylight while the other is plunged into eternal darkness. At first glance, this seems hostile to life, with one hemisphere scorched and the other frozen, but models suggest a twilight zone, a band of moderate temperatures along the planet's terminator, where conditions might be just right for liquid water and, potentially, life. In this narrow strip, winds and ocean currents could distribute heat, creating a stable oasis amid extremes. The study of Proxima b is just one chapter in a broader saga of exoplanet exploration. Across the galaxy, other worlds beckon. TRAPPIST-1e, orbiting a star 40 light-years away, sits in its own habitable zone, part of a system with multiple Earth-like planets. Kepler-452b, dubbed Earth's cousin, lies 1,400 light-years distant, its surface possibly warmed by a star much like our Sun. Each of these worlds adds to our understanding of how common habitable conditions might be, yet Proxima b's proximity makes it uniquely compelling. At just over 4 light-years, it is a neighbor in cosmic terms, close enough to inspire ambitious dreams of exploration. One such vision is Breakthrough Starshot, a daring plan to send thousands of tiny light-propelled probes to the Alpha Centauri system, which includes Proxima Centauri. These spacecraft, no larger than a smartphone, would be accelerated by Earth-based lasers to 20% the speed of light, reaching their destination in just 2 decades. The challenges are immense: navigating interstellar dust, capturing data during a fleeting flyby, and transmitting it back across light-years, but the potential rewards are staggering. Even a single image of Proxima b's surface could rewrite our understanding of the universe. Beyond atmospheric studies, scientists are probing whether Proxima b is geologically active. A planet with a molten core and plate tectonics could maintain a stable climate, recycling nutrients essential for life. The telescope's ability to detect volcanic gases or mineral signatures could reveal whether Proxima b is a dynamic world or a barren rock. Meanwhile, radio telescopes like the Square Kilometre Array, a massive network under construction in Australia and South Africa, are listening for technosignatures, signals that might betray the presence of an advanced civilization. The idea of detecting a deliberate transmission, perhaps a beacon from a society as curious as our own, is a long shot but a powerful motivator. The search for such signals has been ongoing for decades, yet the silence of the cosmos only deepens the mystery. Could Proxima b host a civilization gazing back at us, wondering if they, too, are alone? The data from Proxima b demands caution. Methane, for instance, can arise from geological processes, not just biology. Water vapor might indicate oceans or merely transient clouds. To confirm life, scientists need multiple lines of evidence: an oxygen cycle, complex organic molecules, or perhaps seasonal variations tied to biological activity. The James Webb Space Telescope is just the beginning. Future observatories like NASA's Habitable Worlds Observatory promise even sharper images and more precise measurements. The extremely large telescope in Chile, nearing completion, will complement these efforts, scanning for biomarkers like ozone or nitrous oxide. Together, these tools are building a mosaic of knowledge, piece by piece, about worlds we may never visit but can still understand. The implications of Proxima b extend far beyond astronomy. If life is found so close to home, it could mean the universe is brimming with biology, from microbes to complex organisms. This would challenge the notion that Earth is a rare fluke, a solitary oasis in a desert of stars. Conversely, if Proxima b is lifeless despite its promising conditions, it might suggest that life is extraordinarily rare, a fragile spark that flickered only once in the galaxy's vast history. Either outcome would reshape our perspective on existence. The study of Proxima b also holds a mirror to our own planet. By analyzing its atmosphere, scientists can refine models of how Earth's climate might evolve under stress, offering insights into our fight against global warming. The interplay of gases, heat, and radiation on a distant world could teach us how to better protect our own. The pursuit of Proxima b has sparked a renaissance in space exploration. Documentaries weave tales of distant planets, captivating audiences with visuals of alien landscapes. Books explore the science and philosophy of exoplanets, inspiring a new generation to look skyward. Educational programs are drawing students into astronomy, engineering, and astrophysics, fields that promise to unlock the universe's secrets. The dream of sending probes or even humans to Proxima b feels less like science fiction with each passing year. Technologies like light sails, powered by lasers, and nuclear fusion propulsion are moving from theory to testing. These innovations could make interstellar travel feasible within a lifetime, turning a journey of light years into a human endeavor. Yet with these possibilities come profound responsibilities. If Proxima b harbors life, how should we approach it? Microbial life would raise questions about contamination. Could Earth organisms disrupt an alien ecosystem? Complex life, or even an intelligent civilization, would demand an ethical framework for engagement. Should we broadcast our presence or remain silent, observing from afar? The United Nations Office for Outer Space Affairs is already exploring planetary protection protocols, while scholars debate the concept of planetary rights. What duties do we owe to a world that might host life, intelligent or not? These questions echo the moral dilemmas of Earth's past, when exploration often came at the cost of exploitation. This time, humanity has a chance to act with foresight, guided by the wisdom of our shared history. The journey to understand Proxima b is also a journey inward. It forces us to confront our place in the cosmos, to ask what it means to be a species capable of reaching beyond its cradle. If life exists just for light years away, it could suggest that the galaxy is a tapestry of living worlds, each with its own story. If Proxima b is barren, it might underscore the preciousness of Earth, a singular haven in an indifferent universe. Either way, the search reshapes how we see ourselves. The James Webb Space Telescope, with its golden mirror and infrared eyes, is more than a tool. It's a bridge to the unknown, connecting us to possibilities we've only dreamed of. Its observations of Proxima b are a milestone, but they are also a beginning. Future missions will push further, refining our tools and our questions. The extremely large telescope, with its massive 39-meter mirror, will soon join the effort, offering direct images of exoplanets and deeper insights into their atmospheres. Space agencies like NASA and the European Space Agency are collaborating with private companies to plan missions that could one day reach the stars. Proxima b's orbit, so close to its volatile star, creates a world of extremes. Its tidal locking might produce a planet of stark contrasts, blazing day on one side, frozen night on the other. Yet, in the twilight between, there could be a region of balance, where life clings to existence. Scientists are modeling how winds, oceans, and clouds might interact in such a place, creating conditions unlike anything on Earth. These models are not just guesses. They're built on data from the telescope, which reveals the planet's atmospheric dynamics. Some speculate about life adapted to this twilight zone, perhaps photosynthetic organisms thriving in dim red light or creatures that navigate a world of eternal dusk. These ideas, while speculative, are grounded in the growing field of exobiology, which seeks to understand how life might evolve under alien conditions. The breakthrough Starshot initiative remains a cornerstone of hope for direct exploration. Its tiny probes, propelled by light, could carry cameras and sensors to capture fleeting glimpses of Proxima b. The challenge of transmitting data across light years is daunting, but advances in quantum communication and laser technology offer potential solutions. If successful, these probes could reveal whether Proxima b has oceans, mountains, or signs of life. Even a single grainy image would be a triumph, a testament to human ingenuity. Meanwhile, Earth-based efforts continue to listen. The Square Kilometer Array, with its thousands of dishes spread across continents, is designed to detect the faintest signals from distant stars. A single anomalous pulse could change everything, proving that we are not alone. The philosophical weight of Proxima b cannot be overstated. If life is common, it might mean the universe is a garden, with life sprouting wherever conditions allow. This would challenge religious and cultural narratives, prompting humanity to redefine its place in creation. If life is rare, it places a heavier burden on us to protect Earth, the only known home of biology. These possibilities are not just scientifically or existential. They touch on questions of purpose, morality, and destiny. How would we react to a signal from Proxima b? Would it unite us or divide us? Would we see ourselves as explorers, stewards, or intruders? These questions are already being debated in academic halls and international forums, as humanity prepares for a future that might include cosmic neighbors. The knowledge gained from Proxima b is also practical. By studying its atmosphere, scientists can better predict how Earth's climate might respond to rising carbon dioxide levels or shifting magnetic fields. The planet's proximity to its star offers a natural laboratory for understanding extreme environments, which could inform our efforts to colonize Mars or other worlds. The data from Proxima b feeds into climate models, geological studies, and even the search for habitable exoplanets elsewhere. Each discovery builds on the last, creating a web of knowledge that spans disciplines and borders. The global fascination with Proxima b is palpable. Social media platforms buzz with discussions about alien life, fueled by the telescope's images and data. Artists create visions of Proxima b's surface, imagining crimson skies and twilight seas. Educators use the planet to teach concepts of astronomy, chemistry, and ethics, inspiring students to ask big questions. The prospect of interstellar exploration has galvanized industries, with companies investing in propulsion technologies that could one day carry us to the stars. International cooperation is growing, as nations recognize that the search for life is a shared endeavor. NASA, the European Space Agency, and private ventures like SpaceX are pooling resources, discussing missions that could accelerate our reach into the cosmos. As we stand on the cusp of these discoveries, the ethical questions loom large. If Proxima b hosts life, how do we ensure our exploration does not harm it? Should we treat alien ecosystems with the same respect we're learning to apply to Earth's? The concept of a galactic prime directive, a policy of non, is gaining traction among ethicists even if life is not found. Proxima B's study forces us to confront our responsibilities as a spacefaring species. The universe is vast, but our actions within it carry weight. The decisions we make now about exploration, technology, and ethics will shape the legacy we leave in the stars. The James Webb Space Telescope has opened a new chapter in our story. Its observations of Proxima b are a stepping stone, a glimpse into a future where humanity might touch another world. Future telescopes, like the Habitable Worlds Observatory, will sharpen our view, searching for the chemical fingerprints of life. Missions like Breakthrough Starshot, though ambitious, remind us that the impossible is often just a matter of time. Proxima b, with its mysteries and possibilities, is a symbol of our curiosity, our drive to explore, and our need to understand. Whether it holds life or not, it is a mirror reflecting our hopes, fears, and aspirations. As we gaze at this distant world, we are not just searching for others, we are searching for ourselves, seeking answers to questions as old as the stars. The cosmos is calling, and with every new discovery, we edge closer to knowing if anyone is answering.